Hi everyone, so in this video we will be seeing how the attention mechanism works in detail. Okay, so this is what we are going to do. So we'll start with a question like very simple question. Sunday is a dash, so you have to fill in the blanks. Okay, and the options are Sunday is a car, Sunday is a holiday, or Sunday is a city. Now this is a very simple example, but it's a very important example when it comes to understanding the attention mechanism. So obviously if you're smart enough, you will say this is the option B is correct, right? But I don't really want you to answer the question. What you need to answer is which is the word out of these three words: Sunday, is, and a. Which of these three words were the most important in making sure this particular dash is actually holiday? Let's take another example. Let's say you have something like Tokyo is a dash. Tokyo is a car, Tokyo is a holiday, or Tokyo is a city. Obviously what you will say is the answer, Tokyo is the city. Now the question is not to ask you to basically answer this question. The question is really which is the important word. Obviously in both the cases the important word is the first word, Sunday and Tokyo, which means even though there are more than one words in a sentence, a sentence can have many words, only some words are important and we should be able to figure it out, or rather in other words we should say that we should pay more attention to these words. So how to do this is what we will be seeing in this particular video. So in attention mechanism, so now we are getting into the attention mechanism. Okay, so in attention mechanism, every word that is there in the vocabulary. Now what is vocabulary, other things, I have already made videos on about this on the channel, but don't worry, in the next two videos or other things we will be covering those things, right? So every word is represented by three different vectors. It's called the query vector, it's called the key vector, and it's called the value vector. These are the three vectors, independent vectors. You can see over here, this is a vector, this is also a vector, and this is also a vector. So key is a vector of 5 dimension. It can be any query. A key is also a 5 dimension, and a value is of 6 dimension. Now one thing that you need to understand is this is for every word. Every single word in the vocabulary will have query, key, and value representation. Now how it will have is something we will see later, we will see in the next video, but we will say that it will have all the three representations. One more important thing that you need to see is always and always the query vector and the key vector will have the same length. Okay, the value vector can be of any length. Generally it is greater than the query and key to say vector length. Now here you are seeing this is 5, this has to be 5 if this is 5. Okay, and this is over here 6, it can be 7, it can be 400, whatever, it doesn't matter. Okay, this value vector can be of any length. Now let's move forward. This is what you need to understand. So our sentence was, so we will be taking the first sentence. Okay, Sunday is a dash. So there are 4 words. As I told you, every word will have query, key, and value. So every word will have 3 representations. The first one will be query, key, and value, and same for all the other words as well. Even the dash will have its own query, key, and value. Now what you need to do, you need to take, since we are trying to figure out this word, right, we are trying to figure out what will be in place of the dash. We will take a copy of it on the side. This is just for understanding. Okay, how all of these things work in code is something we will be seeing in the next video, but this is the base. This is how you need to understand. Okay, once this particular task is done, what you will say is, since this is the blank, this is a, you can say it's a question for us or it's a query for us. So since this is a query, we will keep the query. Do we need the key and value right now? No, we don't need the key and value right now, since this is a question for us, this is the query. Now how things happen is, in this attention mechanism, is whatever we need to figure out, whatever we want, we take the query vector of that and we take the key vector of all the other words, including the own word itself. This is a condition that why do we do this, why do we take the query with its own key? It's because in matrix multiplication it's really hard to say which I don't want to do it, I don't want to discuss right now, but let me just give a gist, is that we don't want to break this matrix. Okay, we want to take the entire matrix and multiply it with the entire matrix. You cannot say you cannot say, okay, third row will not be multiplied by the fifth column, something like that. Okay, we just want the entire matrix to be multiplied by the entire matrix. Let's just keep it in the next video, we'll cover all of this. Okay, so what are the things we don't need? We don't need the key and value over here. We only need the query, and we only need the keys and the values of the other words. So can't I remove all the queries of these? Yes, we can. So you see all the queries are removed from here, and key and value of this, whatever we are trying to figure out, this word, this blank is going to remain. So let's remove all of this. Okay. As I said, what you will do, you will take the query of whatever you want to find, the query vector of this, and do a dot product with the key vector of this. Remember, I told you those two vectors have to be equal length. Dot product is only possible if vectors are of equal length. So now you are able to understand why that is the case. So we'll take the query vector of the word that we want to figure out and dot product it with all of these keys, with the Sunday key, with this key, with this key, and also this key, all of these keys. Okay, so you can see over here we did a dot product and we got certain value. Okay, these are random values, don't have to worry. Okay, so the vector I showed you those before, that was also randomly initialized. Okay, now you have a 2.2 score, minus 0.1, 0.3, and minus 0.08, whatever, minus 0.8. It means that the importance of this is high. Why? This is 2.2, positive 2.2. This one is slightly negative, which means the importance is less. Here 0.3, more than this vector, but definitely less than this word, not vector, word. So what this score is telling you is what is the importance of this word in predicting the query. I hope you understand. That is why we are doing dot product. When do we do dot product? When we want to figure out similarity. Here importance is nothing but similarity. I hope you understood. Okay, it's a very important concept over here. Okay, so we needed to figure out, you remember I was asking you a simple question, Sunday is a dash, you said Sunday is a holiday. Which word did you pay more attention to? The word Sunday. And how did we figure out? We figured out by the dot product value. This is what we train in the deep learning model, to figure out the value. Now we'll go in the next video, we'll see all of this. Okay, so we understood that this particular Sunday is the most important word and hence the highest value. Okay, now what we do, we simply take all of these to say vectors, we put it in a line, all of these scores, and put it in a line, and then what you do, you put a softmax to it. Why? Because you know these are negative numbers over here, they cannot be interpreted as a probability. What is the two things that we need to satisfy probability, whatever? Now, two conditions for being a probability. Number one, the summation should be equal to 1, and number two, all of them should be greater than equal to 0. Greater than equal to 0. This is something that this vector is, or these scores are actually satisfying. All the vectors sum to 1, all these, sorry, not vectors, all these numbers sum to 1. So if you add all of this, you will come to equal to 1, and all of these are obviously greater than 0. So what happens? So these were the old values, as you can see over here. We will replace them with the new values. See, yeah, we can replace them, and we have seen 0.77, 0.07, 0.11, and 0.05. Now that we have done both of these, we have already, or to say, found the importance or the softmax scores, do we really need the query and these keys anymore? We don't need, right? We don't need. So we are just going to delete all this. We can also put a cross over here because we are going to delete this as well. So once you delete it, you are only left with these things. So let me now rearrange a little bit. Okay, now you see I have rearranged. Now these are what? These are values, right? So these are value vectors of all those words right here. Okay, so what you do, you multiply all these scores. So this is the highest score, it means the value of this is obviously going to be the highest, or the weightage of this is the weighted sum, right? You know what is a weighted sum. So you can see the weight over here, the weight is the highest, which means the say of this particular value is going to be the highest. So we will multiply all of this, and then we are going to add, you know, this is going to be add, and this will give us the final vector. So what is the formula again? You will have the final vector. This is the final vector. This is nothing but the score of 1 into the value of, so score of Sunday was 0, of the word Sunday was 0.77, and the value vector is over here. Again, the score of the word is 0.07, and the value is over here, the value vector. This is a vector. These are all vectors. Okay, these are not numbers or variables, these are vectors. Again, 0.11 into this vector, and 0.05 into this vector. Okay, hope that is clear. So if you're adding, if you're multiplying with a scalar and to a vector, then again scalar, this is k1, this is a scalar 1 into v1, this is scalar 2 into v2, this is scalar 3 into v3, plus scalar 4 into v4. What is this? This is scalar into vector is a vector. This is again scalar into vector is a vector, scalar into vector is a vector, and then scalar into vector is a vector. If you add 4 vectors, what do we get? We get another vector, you know. So this is going to be another vector which is going to be represented as, this is a random vector. These values are to say random, but you can see this is again a vector. So final vector is actually a vector and nothing else. Okay, so I hope you were able to understand. So this was the entire idea. Basically very simple. Every word in the sentence has query, has a key and a value. These are the three things. Okay, so whatever is the query, whatever is the dash, you take the query of that and then you multiply it with the key, get a score, then you do a softmax of the score, and once you got that softmax score, you multiply it with the value and then add it like this, you get the final vector. Now how we are going to use this final vector is something for the next video. Okay, this is not in this video. So okay, I'll just tell you, this final vector is going to help you in the let's say in getting back that word, whatever the word that we needed for this, we will find a closest embedding. Okay, so I don't want to get into that. We will be doing it in the, maybe not even the next video, when once we'll be implementing it in from scratch and all those things, everything in detail, then we'll be doing it. Okay, so I hope you like the video. If you like the video, please like and subscribe. Thank you very much and bye.